In Malware Development Essentials course, we talked a little bit about PE and PE files and PE format. Now in this course, we will need much more detailed information because we will discuss several techniques which basically require better understanding of PE files and PE headers, etc. Okay. The best source of information about PE format is Microsoft. They have published the very detailed post covering all the details, and they also say that you need about 2 hours to read this stuff. But believe me, if you want to really grasp all the details, you probably would need several days or even weeks to do that. Fortunately, we don't need everything from PE format. We will focus on the most important, like the most crucial from our perspective, crucial things. And but once we are here, I want to highlight 2 things which are important, which will be important later. So there is something called file pointer. It is also known as raw address, okay? And this is the location of an item within the file itself before being processed by the linker. In other words, this is positioned within the file as stored on disk, okay? So file pointer is just an offset within the file on disk, okay? That's basically it. Then we have something called RVA, or relative virtual address. It is an image. In an image file, this is the address of an item after it is loaded into memory, with the base address of the image file subtracted from it. The RVA of an item almost always differs from its position within the file on disk, file pointer. Okay. First of all, if we are talking about RVA, we are dealing with a module or an image already loaded into memory. So we are dealing with addresses in memory. All right. So let's say we have a loaded module into memory, and it starts from address 1000. Okay. So this 1000 is our base address, and from that base address you calculate an offset to the location in memory, and this location is called RVA. Okay, so it's just an offset from the base address to the location we are interested in. So to recap, RVA is an offset in memory, and file pointer or raw address is an offset in a file on disk. Okay, that's the basically difference. In Malware Development Essential course, I told you that PE file is like a book. Okay, it contains a metadata and data. The data is just basically the contents of the file of the book, but metadata is information about the contents. So, for example, who's an author, or what's the table of contents, or what was the date of publishing, etc. Right, and similar metadata lives in PE files within headers, so-called headers. Okay, these are special structures describing information about the information. Sections are basically like chapters in a book. Now, if you take a look at the headers part, it might be a little bit overwhelming because we have like DOS header and a P header and optional header and some data directories and tables and sections. What the hell is this? You can actually view this in a slightly different way. Okay, so if you're looking something, if you want to get from a point A to point B, you follow the road signs. Okay, if you want to go to city X, right? So you jump into the car and ride down the road, and you follow the signs. So P headers are like sort of road signs. So DOS header gives you information about, hey, if you want to find p header, oh, here's the pointer. You go that direction and you will find a p header. All right. Once you're in a p header and you want to find information like, hey, what's the size of optional header? Okay. Oh, and p header, yeah, here is the information. You can find that the size here. Once you are in a optional header, then you get much more detailed information, like if the application is a GUI app or a console application. All right, where's the entry point for the within a P file? In data directories, you can find information like import table, which basically says like, hey, this module needs this and this and this DLL, and from these DLLs we need these functions. We will be using these functions. Okay. The section table is truly like a table of contents in the book. So in section tables is like, oh, chapter 1 is the code, which is executable, so this is our instructions. And the chapter 2 is the read-only data, and the size of this chapter is this. So sections are like chapters, and these chapters you can find after the headers. All right. So that's basically how PE is built. So now let's jump to our VM and yeah, let's do that kind of manual parsing. So for our experiments with PE parsing, we will need a few things. We need a program which allows us to easily view, all the headers and structure within the PE file, and we need a target. So for the target, we will use Notepad, and for the tool for parsing, we will use PEBear, written by Hasherzade. So let's load our Notepad. So we go to C Windows System 32 Notepad.exe. All right, and to make it more like digestible, let's use a header file from SDK. It's called winnt.h. To find it, you can find it from here. So we have include and this one, folder. So we copy. Let's jump there. And winnt header file. Okay, let's open it in the Notepad. And so it contains a lot of definitions, but let's go straight to image format, which has some interesting structures. All right, so let me minimize this and make it more fit the windows so we can see all the needed information. Right here. All right. So we start from DOS header. So DOS header is defined here. So it is a structure with various fields, but there are actually two which are of interest of ours. So the DOS header starts with magic value, which is MZ. You can see it here, MZ. So 44D5A. And actually you can click on this DOS header tab, and all this structure is already parsed in the PEBear tool. It's really incredible tool. I love it. So we have our magic number, and from the whole structure, we need only one value, which is at the end of the structure, which is called ELFA new, which is file address of new exe header. All right, file address. So we're file address, in other words, file pointer or raw address. Okay, so we can see it here. It's F8. So if we follow it, we land in PE header, which doesn't have like a dedicated tab, but let's investigate. So we go to anti-header, right, and let's find the structure definition in our winnt.h file. So let's go to header. So we're dealing with actually with a 64-bit version, and so this structure contains basically three things: a signature, which is 4 byte, right? So it is here, and it is always PE followed by 2 zeros, right? Then we have a structure which is of type image file header, okay, which has its dedicated tab in a tool, file header, all right. And then it is followed by another structure of type image optional header, which also has dedicated tab in a tool. But first let's take a look at this. So we have our signature, and then we have a file header. So let's scroll up a little bit. Probably yeah. So here's a definition of file header. So it has several other members of the structure. So we have a machine, type, sections, count. So this is the number of sections we have in our PE file, and you can see it here. Let's use dump bin and system32 notepad. Dump bin also does the very similar parsing we are doing this right now manually, right? So we have six sections: 1, 2, 3, 4, 5, 6. Okay, so this number is taken from here, and there are a couple of other fields which are not very interesting, apart from the size of optional header, which is F0, and what are the characteristics of this PE file. So we can actually see it here. So it says characteristics, and we have, let me make it a little bit bigger. All right. So we have 22, which is composed of 2 and 20. So number 2 is here, and it says it's executable image, right? And number 20, which supports large, above 2 gigabytes of memory addressing. So yep, that's our image file header. Not very interesting, and it is followed by the optional header. Just keep in mind that this the size of this structure is 20. Okay, 20 is like 2 plus 2 plus 4 plus 4 plus 4. It's 4, 16, 18, 20. So it's accurate, and the signature also has 4 bytes. So if you want to get to optional header, you go to if you want to write a parser, you go to DOS header. From DOS header, you find at the end of the DOS header, you find the raw offset where the anti-header lives. If you go there, you add 24, so it's 16 and 8, and you land in this field, which is the beginning of an optional header. And if you click here, you have 0b, 01, 02, sorry, and yeah, we land in the optional header. So let's find the optional header structure. Does it have? No. All right. So optional header. It is a sort of big structure. It has a lot of fields. So magic number. Actually, is there any definition for that? Yeah, we have 3 magic numbers that defined here. So it's 10b, it's optional header number, optional header for 32-bit. 20b is 64-bit, and 107 is for ROM. And in our case, Notepad is 20b, which is NT64, right? Then we have like linker information, size of the code, size of initialized data. The more important thing is here entry point. So it's an RVA, okay? So an offset in memory, in a process memory, of where the first instruction of which will be executed after the process is loaded. All right, so it's 1AC50, and actually we can click it here. We land in a text section, which we'll cover in a second, but you can also see that there's assembly here. So let's get back to our optional header. Okay. Image base or base address is the address of a virtual memory where this PE file will be loaded, unless there are other circumstances that it may be different. But yeah, from the optional header, you can check the image base address of the loaded image, and there are some other sectional alignments. Not interesting, not important. We have size of image, size of headers, subsystem. I told you about. This is if the value is number 2, you can actually check it here. It's this byte, and actually it's not a byte. It's let me check it out. Yep, it's there are two bytes. So this points you, gives you information what kind of application it is. Is it a console application or with a graphic user interface? And actually it should contain subsystem, yeah, subsystem values. So these are various values for that field. You can be native, which is number 1, graphical user interface is number 2, number 3 is console. So if you load, for example, cmd.exe, you should see number 3 in this field. And we have EFI, Xbox, yeah, even Windows CE has its own value. All right. Then we have characteristics. It is called DLL characteristics, but basically it also works with exe files. And actually, exe and DLLs are not very different from the loader perspective. So what are these characteristics? It says 40, 100, 4000, 8000. It is already, PEBARE already resolves this. What does it mean? But you can also see it in a header file, in a source. So DLL characteristics, we have 40, which is here, which is dynamic base, which means the base address, this base address can actually change while loading. Okay, so the loader is not bound to this value. It can be changed, and we will see in a second how it how it works. Another value is 100, which is NX compatible, which basically means that the stack in the process is non-executable. It's in Windows, it's called DEP, right? 4000 means guard CF, or control flow guard. So this image supports CFG, and 8000 is terminal aware. All right, terminal services aware. And actually, let's load Notepad into the memory, and let's see the characteristics. If you go to me, so these characteristics can be viewed here. Mitigation policies, DEP, ASLR, so high entropy. This is this 40 value. This 40 value, and CFG is also enabled. From that, we can also check the base address. So let's go to memory, scroll down, we have our Notepad, and you can see the base address is different, right? It's 7FF, 7FF, 739, blah, 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 which is different from the base address written here, okay? Which was expected. All right. Then we have more information about stack and some stack sizes, heap sizes, not important. The number of RVAs and sizes. So this field, let me show it in here. This is the field, okay? So this field holds the information of how many members of a data directory are in place, all right? And by default, it is 16 or 10 in hex. And this this structure holds the data directory. So this is like the index, or like a set of information where to look for more information. Okay, so if you're looking for exported functions, export directory is responsible for delivering the information about that. Okay, our Notepad is not doesn't export any DLLs, and keep in mind, exe files can also export functions. That's totally possible. So, but in Notepad case, it doesn't contain anything. Let me first, I forgot to show you how the directory structure looks like. So image directory, it just contains two values, virtual address and size. So it means that each entry in this table it has only 8 bytes, 4 bytes for address, which is RVA, okay, and 4 bytes for size. So let us actually show it in here. Okay, so first 8 bytes is for export directory, and both values are 0 here, 4 bytes, 4 bytes, 4 bytes for the address, RVA for and the 4 bytes for the size. The next one is import directory, which holds some information, and usually it is this directory is part of the PE file because it contains information about what kind of DLLs and which headers, which functions are imported and used by the application. So the import directory gives you that, and it has 0002 17D8, right? So this is our RVA of import address table, and the size is 244, right? And the process goes on and on. We have other directory import table, import address table. It's something a little bit different from import directory. These two things will be discussed in more detail in a later module. For now, there is one more thing I want to mention, is that data directory ends with two empty records, which are here. Okay, so this is the end of data directory. And after that, the data directory is actually followed by section headers. But you can so to get to the section headers, you can jump straight there, like not straight, but not directly. But from, if you recall, from file header, there is a value called size of optional header, right? It's F0. And from the DOS header, we know the location of our NT header. So we jump from F to F0. We know we add 24, which is the size of the signature and the file header, right? So we land in an optional header, which is 110 offset, and we add F0 to that offset, which is 200. If we go to 200, we land in section headers. Okay, so these are two empty records in the data directory. So this is how you can jump into section headers. Before we do that, let's see how we can translate this RVA into the virtual address in memory. So we have our process. So first of all, we need to, let's copy that. We cannot copy. Okay, so we need calculator, and set it to hex. So 1C6B0. This is our RVA for import address table. Okay. So now let's attach a debugger to a running notepad. And in memory map, we go to memory map, we have our notepad. So this is our base address, right? So starting from this address plus RVA of that value, or in other words, this value should point to our import address table in the process. So let's copy address from here. Let's go to a dump and go to expression, paste, plus our RVA, copy, paste. Let's get rid of that space. And we land in some strange place, which is actually our import address table. You can tell it from, yeah, these values are pretty similar as they point to different, points, different virtual addresses in the process memory. So you can verify that with follow keyword in a disassembler. So this particular address points to an open process token function in kernel base. Okay. The next points to another function in kernel base, get token information. Let's take a look at this offset. This points to ETW event unregister, and so on and so on. Okay. So yeah, you can actually see the same thing using Process Hacker. So if we go to memory, notepad, and its base address, it's EDC, it is somewhere here. And address is 1C6B0. Maybe it's 6B0. Let us see. 6B0. Yep, this is our import address table. Right. Some of the values are not yet resolved. Here's an empty one. Here's an empty one. But basically, this is you can see the import address table using Process Hacker as well. All right. Let's close that. Let's close that. Let's jump back to our PE bear. And the last thing left is section headers. So let's find section headers, optional header, anti-headers. We have a section header here. All right. Definition. So section header. It starts with a name, which is of length image size of short name, and is defined here. So it has 8 bytes. So we can see it here. It's .text 000. This is 8 bytes. So this is the first field, right? Name. Then it is followed by the union, but actually it's the union means you can reference this D word by either using virtual size or physical address name in your code. But in reality, it's just one D word field in a structure. So it's 4 bytes. So 4 bytes, 0001 AA35. And you can see it here. It's already parsed by pbear, right? Then we have virtual address, also 4 bytes. So this one, it's 1000. It's RVA, okay. Then size of raw data. So is this one 4 bytes, 01 AC00. That's this field. And it is followed by pointer to raw data. Okay, so 4 bytes, it is 0400, so 400. So this is a pointer in the file, and this is the RVA in the memory. So in other words, this section will be loaded at address, base address plus 1000, okay? And this will be mapped to the byte number 400 and the following bytes, starting from the offset 400 in the file, okay? So 400 in a file corresponds to 1000 offset in the memory of the process. All right, then we have pointer to relocations, pointer to line numbers, and so two 4-byte fields. So this 4-byte is 0, pointer to relocation 0, then pointer to line numbers also 0, and then we have number of relocations and number of line numbers. These are these are just 2 bytes, like 2 bytes, and these are all also zeros, as seen here. And the last field in this structure is called characteristics, which is here, and it is 4-byte, right? 60000020, and this translates, you can translate it here. So 20 is here, so it's code, all right, and 600 is actually a composition of two values. So it's execute, it's 20, and read, and 40. And you can verify that here using dump bin again, headers. So this is what we have seen so far: file header, optional header with data directories, and then we started to parse a text section header for text section, and we have our flags here, right? And this is code, execute, and read. All right. So it means that this section, after it is being loaded in the memory, will be set as execute and read. And we can actually see that in the debugger. In memory map, you can see it. Text section is loaded as executable and readable. All right. And then we have another section header for our data section. Okay, and the same thing goes on and on. So this is how it looks like after being parsed, really nicely laid out. And so this is, as I told you, this is our table of contents, right? So our sections are our chapters, and this is our table of contents. And PEBear also has really nice view of these sections, how they look like in the file. So this is the left pane, the raw view, text section, our data, resources, etc., and how it looks like in a virtual memory. Okay, so these are not perfectly aligned. These offsets are different. For example, the offset of entry point is a little bit different in memory than in the file. All right. All right. So this is how you can view or dissect PE file using PEBear and some information from the source header file.